Hello students, greetings from Taktse International School. I'm going to be your chemistry teacher for another 30 to 35 minutes, and in this session we will cover the topic acids, bases and salt. You can see a presentation behind me on the screen. In this video you will learn about acids and bases. You will learn to identify acids and bases using various indicators. And you will also learn about neutralization reactions. You can see lemon and oranges in the screen. Have you tasted this fruit, student? If you have tasted it, you will know that these fruits taste sour. Now, why do they taste sour? Even when you go to a juice shop and ask for a lemonade or an orange juice, you will know that they taste sour. Why do they taste sour? Have you ever thought about it? The answer is because these fruits contain acids. Now, these fruits are not the only fruits that contain acids, students. There are other fruits and other food in this world that contains acid in them. Some of the examples are tamarind, vinegar, etc. Now, because these fruits contain acids in them, they have acidic nature. You can see the screen behind me. I have written it down. ACIDIC, acidic in nature. Now let's move on to another subtopic, and that would be bases. Have you washed your hands with soap? You must have. And when you do, what do you feel? When you wash your hands with soap, you feel slippery to touch. Why is that so? This is because soap contains base, right? Because soap contains base, you feel slippery, your hands feel slippery when you touch soap or when you have soap solution in your hands. Okay. Now, this is not just the only property of the bases, students. Bases also have another property by which you can identify them, and that is through taste. Bases are bitter to taste. Have you tried testing baking soda, which you can commonly find in your kitchen store? Try tasting it. You will know that it tastes bitter. Why does it taste bitter? Again, because it contains bases. Now, substances that contain bases in them, they are called basic. Their nature is basic, and how you spell it? It is spelled BASIC, and you can see that on the screen. Well, if I give you an acid and a base, and then I tell you to identify which one of those is an acid and which one is a base, without tasting them, how would you identify them? You cannot taste all the acid in the world, students. So, scientists have developed a very fascinating method of identifying them without tasting them. Substances that help you in identifying whether the given solution is an acid or a base are termed as indicators, because they indicate whether the solution is acidic or basic. That's the reason why you term those substances as indicators. How is it spelled? It is INDICATORS, indicators. I'm going to show you the list of activities to indicate or to identify whether the solution given to you is acid or a base. Some examples of indicators are litmus paper, turmeric powder and China rose. There are two forms of litmus paper available. They are red litmus paper and blue litmus paper. If you see on the screen carefully, I have made a table. You can see red litmus paper, blue litmus paper. Now, how do you think these litmus papers will indicate whether the solution is acidic or basic? If you take red litmus paper into an acid, which means if you tear a paper and throw it into a container that contains an acid, it will not change. By that I mean the color of the paper will not change. It will remain red. But if you throw a piece of paper into the container containing base, the red litmus paper will immediately change its color and it will turn blue. Similarly, when a blue litmus paper is dipped in a solution containing an acid, the blue litmus paper will immediately change its color to red. However, it will show no effect when you dip that paper into a container containing base. I have two solutions in the conical flask. This is the lemon juice and this is the soap solution. Now, so far you must have understood that lemon solutions are acidic in nature and soapy solutions are basic in nature. Now we will learn to identify, or rather say see, how litmus paper will show its property in the presence of an acid and a base. I have a red litmus paper and a blue litmus paper. I'm going to use a dropper to pour lemon solution into each of these. Let's first pour it in the red litmus paper. Do you see any change? There is no change. We will now pour it into a blue litmus paper. Do you see a change? The blue litmus paper immediately turned red in color. So, litmus papers is one way you can identify whether the solution is acidic or not. We will now see how litmus paper will behave in the presence of a base, that is a soap. Let's pour this into a blue litmus paper and you will see that there is no change in color. Let's do the same on the red litmus paper and you will see that it has immediately changed its color to blue. In this way, students, you can identify whether a solution is basic or acidic with the help of two litmus papers. Those are red litmus paper and blue litmus paper. There's another thing I would want to inform you, students. These litmus papers are made out of a plant called lichens, Lichens. I have a turmeric solution and let's pour it into the petri dishes. Now let's pour lemon solution into these petri dishes. Do you see any change? There is no change. Let's pour soap solution into this. Do you see a change, student? The color immediately changed to reddish brown color. Look at the difference. What did you observe? Acids don't change their color in the presence of turmeric powder, but bases change their color from yellow to reddish brown in the presence of turmeric powder solution. So this is one way of identifying whether your fruit contains an acid or a base, whether the solution given to you contains an acid or a base. Have you ever wondered, students, that when you wash your clothes stained with turmeric, with a soap or a detergent, the stain turns pink? Now why does that happen? Have you tried thinking about it? That is because the turmeric stain acts as an indicator, It indicates the soap or the detergent powder that you have used on it is a base or an acid. There's another example of an indicator, and that would be China rose. And here's an activity for you students. I would want you to experiment this at your house or maybe at your school later when the schools reopen. All you have to do is buy a China rose or pluck it if you have it in your garden. Take the petals from the China rose, rub it on the piece of paper, let it dry. Once it has dried, you have to cut that piece of paper into thin strips and then try it with various food items that's available at your house. Maybe lemon or maybe oranges for an example. Let's see on the screen how it behaves in the presence of an acid and a base. China rose in the presence of an acid, that is, in the presence of lemon or oranges that contains acid, will change its color from red to bright pink. And in the presence of base, it will change its color from red to green. That is how you can identify whether your fruit or a food contains an acid or a base using China rose as an indicator. So from all these experiments that you have seen today, how can you define an indicator? What is an indicator? An indicator is a substance that changes its color in the presence of an acid and a base. There's another subtopic we are going to learn about today, and that would be neutralization reactions. You will see neutralization reaction and its property in the screen a little later. Let's first do an activity that will help you understand neutralization a little better. From the previous experiment, you know that turmeric powder will not change its color in the presence of an acid, but it will change its color from yellow to reddish brown in the presence of a base. Now, let's take turmeric powder into one of the Petri dishes. Let's take soap water, which is a base, into this. Do you see the change in color? Now let's pour lemon water into it. What did you notice? The color again changed from reddish brown to yellow, which means when I had a base in the Petri dish, the turmeric powder was reddish in color, but when I added a lemon solution to it, the turmeric powder regained its color. What has actually happened in this Petri dish? I'll tell you. The amount of soap water that was present in the Petri dish was equal to the amount of lemon water which was later poured into the Petri dish, which cuts the property of bases. So neutralization reaction is when an acid and a base is in equal quantity. An acid cuts the property of a base and a base cuts the property of an acid. So now this solution that you have here is neither acidic nor basic. This solution is neutral, and hence this reaction is called neutralization reaction. Neutralization reactions are reactions where an acid reacts with a base in order to form salt and water. Now, when a neutralization reaction is carried out, it also produces heat. If you touch the Petri dish, you will feel hot. Why? Because a neutralization reaction has just occurred in this particular Petri dish, and this solution is a salt now, students. So neutralization reaction will form salt and water. with the evolution of heat. Neutralization also happens in everyday life. Have you ever had stomach ache due to indigestion problem? That is because when your stomach secretes a lot of hydrochloric acid, your stomach pains. And in order to get a relief from the pain, you take a medicine. The medicine is milk of magnesia, which contains magnesium hydroxide, and that is a base. So when your body secretes an excess of acid, you take the medicine. The medicine, which is a base, cuts the effect of an acid, which means the effect of an acid is neutralized by the base that you take in the form of a medicine. Another example is an ant sting. When an ant bites you, it injects an acid into your body. The acid is formic acid. And in order to get relief from that pain, all you have to do is go into your kitchen store and apply baking soda in it. You will immediately recover from the pain. Another common example is when farmers use excess of fertilizers. A chemical fertilizer contains a lot of acid, guys, and it immediately affects the crops and the plants. In order to neutralize the effect of an acid, another base, which is calcium hydroxide or calcium oxide, is used. You can see the screen behind me. Thank you, students. I hope you have enjoyed the video and the learning today. I would want to remind you of an activity. You are to carry out an experiment at home using an indicator, China rose. You can carry out this experiment with an orange to see whether an orange contains an acid or a base, and the procedure is mentioned in the video. Thank you, and I hope you have a great day ahead.